going to be jumping back into things today with solving by elimination. We have already done by graphing. We're going to get away from that for a day here. We've already done by substitution for a couple of days. That we will revisit a little at the end of the lesson. And now we're going to spend our first of 2 days on solving systems by elimination. So, what does that mean? Well, let's take a peek. And again, this is the skinnier note packet that we're looking at here. So, when are we going to do elimination? Okay. If both equations are in what's called standard form. Now, reminder on standard form. That just means you've got like x plus y on the same side or x minus y on the same side, and then there's a number on the other side. So if we're seeing something like that, where it's not easy to graph because it's not in y equals, it's not easy to do substitution because I don't see x equals or y equals, this is our other option. And what we hope for in this situation too is that one of your sets of variables has opposite numbers. 2x and negative 2x, 5y and negative 5y. So they eliminate each other. So today, that's going to set up nice for us every single time. So it's a nice introduction. So my first job today is we're going to add the equations together. One variable is going to be eliminated. So here's what I'm going to do today for each of these. I'm going to look first and I'm going to see which variable is opposites. And I'm just going to kind of box that in before I start. And so my first step is to just add down. Well, when I do that with the x's, 3x and negative 3 cancel. That's the idea of elimination. Then negative 6 plus 10 is 4. Again, you do have to pay attention to signs. Just because we're adding doesn't mean it gets bigger every time. And then negative 13 and negative 3, if you're not sure, it is not bad to take out calculus. So we do that, and all of a sudden we're down to a one-step equation. So we do our division. And I've got my first variable. Now I will say here, it doesn't mean that every single time you're going to get y first. Sometimes you're going to get x first. It just depends on which variable goes away. And so once you have that, we're ready for step 2. So step 2 is to substitute the value you just found. The answer, okay, so substitute the value found in step 1, the answer, back into one of the equations and solve. It does not matter which one you plug it into. So if you think one of them looks easier than the other, that's the one I'd use. In this case, I'm just going to use the top one. So I'm going to take this and I'm going to start copying this equation until I get to the y, because I know what the y is now. That's where the substitution part of this comes. So all we did here was we substituted negative 4 for y in the top equation. Now, if you can visually just look and see that, maybe you don't want to write that. But sometimes it helps when you go back later, you're like, where did you just come up with that from? You just pull that out of thin air? No. I took y out and just replaced it with the number. And now, what that allows me to do, again, there is no shame in letting the calculator help us here. I got negative 6 times negative 4, which is positive 24. And now it's back to a regular old first semester Algebra 1 equation. So now I just want to get x by itself. I undo my plus 24. And I am not going to run out of room. I am not going to run out of room. Again, if you're not sure, -3 minus 24. It's better to use the calculator than to try and do it off the top of your head and get some crazy answer. And I get the -9. And we're set. And once I've got those two, I'm good to go. So I say, at least pretend for me. At least pretend. So that's basically all we're looking at with elimination. Now, as I said on the first one, when I start at the beginning, if I look like I'm going to be adding down, which is my first step, 2 and 3, that's not going to cancel out. So, okay, my x's are still here. But I look here and I'm like, ooh, positive and -4y. They're opposites. They're going to cancel. So in today's questions with elimination, that's going to happen every time. And so once I get that first step out of the way, it's just that one quick division step. And just like that, your first value is found. We jump back in. Again, either equation doesn't matter. So let's say this time, I'll just stick with the top equation, that's fine. To this time, I know what the x is. So that's what I'm going to replace. I've got to make sure I replace the correct variable because it matters. And so once I take that x out and replace this, I only have one variable left now to solve for. So I go ahead, I get this set. And now we're back into semester 1 mode where, hey, I want to get the y term by itself. I got to undo what I did not put in the box here. So I do the opposite. And really here, I would say the trickiest thing is going to be reminding myself, I don't want a plus 4 to both sides. That's not y minus 4 or -4 plus y. It's -4 times y. So we're going to divide by -4, and negative divided by negative is positive. So these first two examples are what our normal elimination would look like. It's just one we solved for y first and then x. The other one, the y's canceled. We solved for x first and then y second. That's what most of them are going to look like. You're like, let me guess, Hardy. Special cases are coming. They are. It's the same things, just in a different look again. Because I look at this next one and I go, okay, if I add down 2x and -2x, cancel. Negative and positive 5y, cancel. It's not that I have nothing left on the left. I have a 0. 7 minus 7, is also 0. Okay, quick chance for review. No x's or y's left, but the two sides are equal. How many solutions am I going to have? Think I heard it?
Infinite.
Infinite. And the nice thing about that one is I don't have to do any other work. What that means is what works for x and y in one equation works for x and y in both every single time. It's not just one place. That's kind of cool. That makes our life easier because this statement was true. But if we change the roles and we go to do the next one and we see the same thing start to happen again, 3x and negative 3x, they cancel. Negative 4 and positive 4y, they cancel. But 6 plus 6 does not cancel. That equals 12. 0 does not equal 12. This is not true. That is false. So how many solutions will we have here? How many solutions do we have when our statement is false? So when all the variables go away, it's one of those two. Is the statement true? Do the two sides equal? Do they not? If they do, it's infinite. If they don't, it's no. That's all the options that we have. Now, don't let this go too far. In the practice packet, and again, if you hadn't gotten around to getting yours numbered before, kind of flip through a few pages, look for this up at the top. This would be your easiest way of seeing what's going on here. So with all of these, one of the two situations that we've run into is going to happen. So let's see what we got rolling here. So I look at number 2. And I go, okay, let's see. 5x and negative 5x. Okay, they're gone. Ooh. 8y and negative 8y. They're gone. All right, special case time because there's no variables left. 22 minus 22 is 0. This, again, is why I always say, if you've got the notes, it's almost like you have a cheat code for what's going on. You're just going to have to be able to point it out. Now, again, that's not going to happen on everyone. It will not happen at times. Let's play with 3 so we don't think everything's going to pop up roses here. Remember, if you don't see a number in front of a variable, there is a 1 there still. So when I'm adding down negative 2 plus negative 1, okay, x's did not go away this time. 7y and negative 7y go bye-bye. Negative 24 plus 9. Negative 15, we got one step to do. What's my one step? How are we going to get x alone? Divide by negative 3. Negative divided by negative is positive. So first step, ready to rock and roll. Second step, again, your pick, either equation. I'm just going to keep rolling with the top. When you get to the variable you just solved for, x in this case, take out the x, substitute it with the value you know, and copy everything else exactly that you see for that equation. And go into an expert equation solver mode. The goal is to get the variable alone. That's why I like to box it. Whatever's not in the box, I got to go bye-bye. We got to undo that minus 10. And if we take our time and use the tools we got, This stuff is doable. Regular case, special case, you're always going to see one of those two. Okay, last one I want to chat with you, and then encourage you greatly. Do these right away, or once I do this other one, we're going to do one substitution for review. If you haven't done that, go back and do that while it's fresh in your mind. And that way, when this quiz comes early next week, we get you off to a great start instead of going, Okay, so the substitution problems are different. I'm going to do the one where I was seeing people have the most difficulty before. These, just set them equal. You literally are just going to be like x plus 4 equals negative 3x plus 16. That's as far as I'm going on that one. But this one, if I find an x or a y equals, and this is why, again, we want to know the different forms, because different forms make different things easier. So here, since that says y equals, I'm going to replace the y with that. So my first step, I start copying that second equation until I get to y. Y is now gone. I even scribbled it out, because that's what y is. So here, we just substituted the box in for y. Before we go any further, we want those parentheses to go bye-bye. So we're going to do a little distributing. 4 times 5 is 20. 4 times negative 9 is negative 36. And then we got to remind ourselves of one thing. And that's this. Oops, not there yet. These x's are on the same side of the equals. They're not on opposite sides like we are on 13. They're on the same side. So just combine them. Do not do opposites. And now we're back into Algebra 1 mode, officially, for first semester. I do my opposite to undo over here. Again, add that 36 to both sides. Oofda! I was wondering if I was going to get there. I did. We substituted that in. We solved it. I did mean to have a 2 there. Why did I erase it? But the nice thing with substitution is, when we go to do that last step, you're like, I have a last step? Yeah, we still got to find y. That last step, and why I number all my steps like this, is remind myself, oh yeah, the y equals 1. If I start copying that, I'm going to replace the x, because I know what that is now. Five times 2 is 10. 10 minus 9 is 1. So again, a little substitution practice. Mainly, we're getting this elimination stuff on lockdown. So take some time.